Good morning, boys. So today we're just going to look a little bit more at the axis of symmetry. So the axis of symmetry of a parabola, if you think of a concave up parabola, the axis of symmetry goes straight down the middle. So it acts like a mirror and reflects one half of the parabola onto the other half of the parabola. It's a line. When we put an axis of symmetry in, we will draw it in as a dotted line. So any question, just a minute, I'm just checking something here. So any question where they ask you to draw in an axis of symmetry, just draw it in as a dotted line. But it should be straight. I haven't done mine straight, but use a ruler and just mark it dotted along your ruler. Sometimes I'll call it just an axis. The world, the Earth spins on its axis. It actually is spinning on an axis of symmetry, but they don't say that. So an axis or an axis of symmetry is the same thing. You will notice that the axis of symmetry will pass through the vertex of the parabola. It has to, because it's splitting it into two halves, and that happens right on the vertex. So the vertex will lie on the axis of symmetry, or the axis of symmetry will pass through the vertex. Alright, so the equation of the axis of symmetry, we've already done this earlier, but I've written it down again. So it's x equals minus b over 2a. It is the equation of this line. It's the equation of the axis of symmetry. So if it's an equation, it has to have an equal sign, and it has to have a left and a right hand side. So you can't just say the axis of symmetry equals minus b over 2a. It makes no sense. It is an equation of the axis of symmetry. It must start with x equals. Now when you get into senior school and you do year 11 and 12, they will start developing some more parabolas that are sideways parabolas. Those axes of symmetry will be horizontal, and they'll start with y equals, but we don't do those in year 10. So all of ours are going to be x equals minus b over 2a. The a and the b come from the same spots as they have in other formulas we've used, like the quadratic formula. So if we have y equals ax squared plus bx plus c, written with the x squared term first, then the x term and then the number, the a is in front of the x squared, and the b is the number, including the sign, in front of the x. Okay, now I'm just going to go into an extension here. You don't need to know any of this for year 10, but I'm just going to explain it because some of you will understand what's going on, and just some of the concepts we're doing here will help you in some of the sort of harder things that you might do in year 11 and 12 when you're dealing with some algebraic things. So I'm going to go through it anyway. So we're going to look at where this formula comes from for the axis of symmetry. If we go back to finding the x-intercepts for the parabola, we would be making y equals 0. So over here we would be putting a 0 in that spot, and you would have a quadratic equation to solve. When we solve that quadratic equation, we would naturally be trying to factorise and solve it, but if we can't factorise it, we would be using our quadratic formula. So this is one way that we could find the x-intercept. So we're going to look at this. So we know that the vertex has an x-coordinate that is the average of the two x-intercepts. That's the way we were doing vertex last lesson, by averaging the two x-intercepts. So we're going to look at doing that. So here are our two x-intercepts split, one with the plus and one with the minus. So we're going to average those two things so that we can find the x-coordinate of the vertex. So if we do that, we're going to add them together and divide by 2. Now it becomes a very messy thing here, but it works. Alright, so I know we've got a light shining over this I can see on the screen, so hopefully by the time we get to the next line you'll see what it should have been. So we've got all of this added to all of this and divide by 2. That's how we do an average. We're adding two things together and dividing by those two things. So if we keep going, these have got a common denominator of 2a up there on the top, so I'm going to keep that common denominator and just put the top two things together. Now we're going to collect like terms. Minus b minus b. Minus 1b minus 1b is minus 2b. Now this bit here, you've got minus something plus something. They cancel out and give you nothing. So if we had minus 7 plus 7, that'd give you nothing. Minus 4 plus 4 gives you nothing. minus root b squared minus 4ac plus root b squared minus 4ac gives you nothing. So they're all gone. It's over 2a, and then we've got it over 2 again. So if we simplify this, we can cancel that out, and it becomes minus b over a on the top, and then we're dividing by 2. Dividing by 2, we can times by the reciprocal, 1 over 2, and if you times your tops and times your bottoms, you get minus b over 2a. So we've actually found our formula. Now some of you might be going, well, I could have done that a lot easier, and yes, we could have. So back here, if you were smart enough to look at this and go, if I'm averaging those two things, aren't I just going to get minus b over 2a? Yes, you are. So for any of you that can see that, because what really is happening is you've got minus b over 2a in the middle, then we've gone and we've subtracted a bit and we've added a bit, but we've subtracted the same thing in both of those cases. Right, so we've got minus b over 2a. And really what we've done is subtract root b squared minus 4ac over 2a and added root b squared minus 4ac over 2a. But by the time you add those two things together, a minus and a plus, they actually are gone. So the middle of it is right here, minus b over 2a. So you might have been able to see that without going through all of this working. That would be great. If you can see it, fantastic, because you're probably going to cut a lot of the things down in working for extension 1 in year 11 and 12 if you can understand that now. So what we ended up with here was the x-coordinate of the vertex. Remember, we find that by averaging the two x-intercepts. And the x-coordinate of the vertex is the same thing as the axis of symmetry, right? That vertex has two coordinates. What we were finding was this one. So whatever that x-coordinate is, that is what's going to be the equation of this. Alright, so it's not the y, it's the x-coordinate, because it's x equals something. It's going to be exactly the same as the x-coordinate of the vertex. So in the next video, I'm just going to do some examples on this. If you got lost in that, it doesn't matter. Write it down anyway, but don't panic if you didn't understand this extension I just did then. Okay? You just need this and the examples we're doing in the next video.